Welcome back to the Deep Dive.
Great to be here.
Today we're tackling something really core to modern warfare, I think. If the military runs on data, on algorithms, what does that do to the inherent messiness of war?
Right. The fog, the friction, the human error. Does AI just wipe that away?
Exactly. And we're looking at a source today that does something fascinating. It takes Clausewitz, the foundational military theorist.
Can't get more foundational than Clausewitz, really.
And it drags his concept of friction right into the age of artificial intelligence.
Yeah, it's a really dense, but I think essential piece of analysis. It argues AI doesn't eliminate uncertainty. It transforms it, creates entirely new kinds.
And it's not just theory. The source ties this into current U.S. doctrine, right?
It does. It fuses Clausewitz with things like Joint Publication 3.0 on operations, 6.0 on communications.
And those DARPA Mosaic Warfare ideas we've touched on before.
Exactly. Trying to give a unified picture of what this all means for the future fight.
So, the mission for us today, for you listening in, is really to pull out the key insights here. How does AI actually change warfighting? We're talking systems design,
Leadership, training.
and even high-level policy. What are the new rules when decisions happen at machine speed, not human speed?
Well, to get there, we really have to start with the original idea. Clausewitz's friction.
Right. Define the classic term first.
So for Clausewitz, friction was basically the gap, the space between the clean, rational war plan you drop.
And the absolute mess that happens when you try to execute it.
Precisely. His famous line captures it. Everything in war is simple, but the simplest thing is difficult.
Yeah.
It was all those small, unexpected things piling up. Bad weather, troops getting tired or scared, orders arriving late, mud.
Yeah.
Just the inherent resistance of reality.
Things that slow you down, introduce error, the friction of the physical world.
Exactly. Born in the era of muskets, railroads, friction defined by scarcity.
Not enough intel, slow logistics, bad roads, that kind of thing.
Right. But here's the pivot in the source material. AI doesn't solve that friction.
It introduces something new.
Something fundamentally new and potentially more dangerous. Algorithmic friction.
Algorithmic friction. Okay, unpack that. What is it?
It's the modern version. We've swapped the old problems, scarcity and delay, for new ones. Problems defined by saturation and opacity.
Saturation, like too much information.
Exactly. Data overload. And opacity, meaning systems we can't fully see inside, biases baked into the code.
The black box issue.
That's a big part of it. Plus, the risk of adversaries deliberately messing with our data to confuse the systems. It's a whole new landscape of uncertainty.
So if the old friction was like a fog hiding things, the new friction is more like a data blizzard. So much stuff flying around, you can't find what matters.
That's a really good way to put it. It overwhelms human cognition. That shift is critical.
Okay. So this deep dive then, we're going to break down this new algorithmic friction. You said there are different forms.
That's right. The source identifies three main types: informational, algorithmic, and organizational. We'll get into each.
Okay. And then we'll link AI back to Clausewitz's big framework, the remarkable Trinity.
Yep. Passion, chance, and reason. See how AI interacts with those.
And finally, look at solutions, policy ideas.
Yeah, concrete things like designing for constructive friction and ensuring positive human control. That's the plan.
All right, let's dig into that transformation then. Moving from that industrial age scarcity problem to this AI age problem of saturation. How has the basic nature of uncertainty changed in warfare?
Well, the source argues it's basically flipped. It's an inversion.
It's an inversion. How so?
For centuries, the big problem was not knowing enough. Tactical blindness, the classic fog of war.
Right. Not enough spies, slow messengers, couldn't see over the next hill.
Exactly. Insufficient intelligence, slow comms, limited recon.
Yeah.
Today, totally different beast.
It's data saturation.
Data saturation and cognitive overload. We're just drowning in data. Think about all the ISR platforms.
Intelligence, surveillance, reconnaissance, satellites, drones.
Yeah, plus cyber sensors, open source intelligence. It's pouring in at a rate that humans, frankly, just cannot process effectively. We can't filter it, interpret it, validate it fast enough.
It's kind of ironic, isn't it? We spent decades, probably trillions, building sensors to get more information. And now the sheer volume of information is the problem, a new kind of friction.
That naileth first type, informational friction, saturation. This overwhelming amount of data creates a really paradoxical risk.
Paradoxical how?
Because Adding more data feeds, throwing more sensors at the problem can actually increase your uncertainty.
Wait, how does more data make you less certain?
If the sources are correlated, basically telling you the same thing in slightly different ways, or if the data is contaminated, maybe by adversary deception, or if your analysts or systems just can't triage it properly because there's too much, adding more noise doesn't help you find the signal. It can actually slow you down or lead you astray.
And the source highlights a specific danger that comes from this saturation. Something about tempo over truth.
Yes, that's a critical operational risk. Prioritizing speed over accuracy.
Okay.
Think about the OD loop. Observe, orient, decide, act. AI is fantastic at compressing the orient and decide parts, doing them at machine speed.
Right, that's the promise.
But if you compress those stages faster than you can actually validate the information, check its source, its accuracy, rule out deception.
You're acting on potentially bad information just really, really quickly.
Exactly. You're prioritizing tempo over truth. And even a tiny error or a clever piece of enemy deception gets amplified and acted on almost instantly. The consequences can be huge.
So this isn't just a technical issue with data pipes. It's framed as, what, a failure of discipline?
Precisely. The source points to Joint Publication 6.0, the comms doctrine. JP 6.0 talks about this in terms of assuring data quality, especially when the enemy is jamming you or trying to spoof your sensors. The doctrine basically says, look, if you have near infinite data, you need ironclad discipline about what you trust, what you prioritize, what you act on.
Because the speed of the machine raises the stakes if you trust the wrong thing.
Massively. The cost of misplaced trust is higher than ever before.
Okay, so that's the friction from the sheer volume of data. But what about the machine itself? The algorithm that's supposed to sort through all that saturation, that causes friction too.
It absolutely does, and that's the second form. Algorithmic friction. Bias, drift, and opacity.
Bias, drift, opacity. Let's break those down.
These are limitations inherent in the AI models themselves. And the key point is, these aren't just minor technical glitches. They're potential strategic liabilities. They act as friction.
Okay, starting with bias. This feels like a familiar concern with AI generally.
It is, but with potentially lethal consequences in this context. The main issue is training data bias.
How it learned in the first place.
Exactly. The source uses a great example. Imagine you have a really sophisticated AI targeting model. It's been trained extensively on satellite images from, say, arid desert environments. It gets really good at spotting tanks hidden in wadis, things like that.
Okay, makes sense.
Now, what happens if that military unit with that AI suddenly deploys to a dense urban area or a triple canopy jungle?
Well, the things it learned to look for, the visual signatures, the patterns, they're completely different.
Precisely. The model starts to underperform, maybe drastically. It might misidentify buildings as threats or fail to see camouflaged enemies in the jungle.
So it misallocates firepower, misunderstands the enemy's actions.
All because it's applying desert logic to a jungle problem. The friction comes from the mismatch between its training and the current reality. It's a bias baked in from its history.
And that seems directly linked to the next issue you mentioned, distribution shift.
They're very closely related. Distribution shift happens when the real-world data the AI is seeing now starts to look statistically different from the data it was trained on.
The environment changes.
The environment changes, the enemy changes tactics, new equipment shows up, the distribution of the data shifts. Think of a self-driving car trained only in sunny weather suddenly hitting a blizzard.
Yeah, the rules, the sensor inputs, everything's different.
Right. The model's performance degrades rapidly because it's operating out of regime, outside the conditions it was designed for. In combat, this happens constantly. The enemy tries to make this happen.
Okay, so the model's performance degrades, it gives wonky results, but the commander needs to know why it's wrong to be able to override it confidently. Which brings us to opacity.
The black box problem, yes.
Why can't we just see how it reached its conclusion?
With simpler AI, maybe you could. But with the really powerful deep learning models, the decision-making process involves, millions or billions of parameters interacting in incredibly complex ways. It's often computationally impossible for a human to follow the exact path in real time.
So the AI says, target X, 98% confidence.
Right. And the commander looks at it, maybe their gut says something's off, but they can't easily interrogate why the AI is so confident. They don't know what features it weighted, what data it prioritized, what its known weak spots are in this specific situation.
Which makes it hard to trust or hard to challenge.
Exactly. That opaqueness is friction. It hinders the commander's ability to apply their own experience and judgment effectively. It creates a risk of just going along with the machine, even if it's subtly wrong, potentially leading to mistakes or even, unintentional escalation.
Okay, so informational friction, too much data. Algorithmic friction, untrustworthy or opaque data processing. What's the third kind?
The third form is about us, the humans, and how we organize ourselves. Organizational friction. The temptation of centralization.
The org chart problem.
Kinda. It's about how the technology pushes us towards certain structures. The promise of big data, AI-driven fusion. Think JADC2 in the U.S. context.
Joint all-domain command and control. The idea of connecting everything.
Right. It's incredibly tempting to say, let's build one giant central hub, one brain, to process all the data from all the domains, land, sea, air, space, cyber, and coordinate everything perfectly.
Maximum efficiency, total situational awareness. Sounds great on paper.
It sounds fantastic.
But
Clausewitz rolls in his grave.
pretty much. Clausewitz would immediately flag this as creating a massive Schwerpunkt.
The center of gravity.
Exactly. That single, all-powerful hub becomes the enemy's #1 target. If they can take out that central brain kinetically, through cyber attack, jamming.
The whole system collapses.
Yeah.
A single point of catastrophic failure.
Precisely. The drive for perfect centralization creates perfect vulnerability. That's organizational friction. The structure itself becomes a liability.
So the tech pushes one way, centralize.
Yeah.
But classic military wisdom, doctrine, pushes back.
It does. And the source points specifically to Joint Publication 3 the Operations Doctrine, and its emphasis on mission command.
Delegated authority, commander's intent. Right. Disciplined initiative. Pushing decision-making down to the lowest appropriate level. The whole point of mission command is to maintain tempo and effectiveness even when communication links break. Which, in a real fight, they inevitably will.
So the doctrinal solution anticipates the failure that centralization creates.
It has to. The key takeaway here, especially for the people designing these AI-enabled C2 systems, is crucial. Don't aim to build systems that prevent failure or degradation. That's impossible in war.
Aim for.
Engineer systems and train teams to degrade gracefully. Assume parts will fail. Assume links will be cut. Design for resilience, for the ability to patch together working solutions from the remaining pieces, guided by that clear commander's intent. Failure is inevitable. Resilience is the goal.
Okay, so we have these new forms of friction, but the source insists we need to anchor AI within Clausewitz's bigger political picture, his remarkable Trinity.
Yes, because technology changes how war is fought, but not why or its fundamental nature as a political act.
Remind us, the Trinity is passion, chance, and reason.
That's right, 3 tendencies constantly interacting. Passion represents the raw violence, the hatred, the irrationality primarily associated with the people.
Okay.
Chance represents the uncertainty, the probability, the fog and friction of combat itself, primarily the domain of the military.
Got it.
And reason represents war's subordination to policy, the rational calculation, the political objective, primarily the responsibility of the government.
So how does AI change the interplay between these three? It doesn't replace them, you said?
It doesn't replace them, it mediates them. It acts like a lens or an amplifier.
Okay, let's take passion.
Passion, the people's element, is now heavily shaped by information warfare, right? AI can generate deepfakes, spread disinformation, target specific populations to incite hatred or crumble morale much more effectively. It amplifies the irrational.
Makes sense. What about chance, the military's domain?
Chance gets amplified dramatically. Autonomous systems operating at speed mean small errors, unexpected glitches, or those distribution shifts we talked about, can cascade into major strategic blunders incredibly quickly. Faster than humans can often react. The role of random events, of luck, is arguably heightened by the speed and complexity.
And reason, the government's policy side.
Well, theoretically, AI supports reason. Think advanced analytics, predictive modeling, dashboards giving leaders real-time data.
The promise of more rational, data-driven decisions.
That's the promise. Better resource allocation, clearer understanding of risks, aiming to make war more of a calculated instrument of policy.
But even with AI supporting reason, the core Clausewitzian principle holds.
Absolutely. The source is emphatic. Violence must remain subordinate to political purpose. Reason has to stay in charge.
So the biggest challenge isn't just making the military faster or more lethal with AI.
No. The primary challenge is preserving legitimacy, ensuring human control, maintaining accountability. If we lose sight of the political goal because we're chasing machine speed perfection, we've already lost the plot.
Which leads directly into some major policy implications.
Critical ones. The source flags, too, as paramount.
First one being?
Mandate positive control. This has to be a non-negotiable red line.
Positive control meaning?
Meaning political leaders and military commanders must retain active, affirmative control over any irreversible actions, especially lethal force. It's not enough to have a human who could theoretically stop the machine.
It needs a positive go command from a human.
Yes, an affirmative authorization for every lethal action. And critically, this needs to be backed by technology, immutable audit trails, time-stamped approvals, data logs that prove who authorized what, when, based on what information.
So accountability can't be fudged or blamed on the algorithm.
Exactly. Accountability has to be traceable and undeniable.
Okay, positive control. What's the second key implication?
It flows directly from the first, the necessity of algorithmic literacy.
We touched on this with opacity. Commanders need to understand the tools.
They absolutely do, because mandating human control is pointless if the human in the loop doesn't actually understand what the AI is telling them or how reliable it is.
So what does algorithmic literacy mean in practice? Do commanders need to learn to code?
No, the source is clear on that.
Yeah.
It's not about becoming data scientists. It's about becoming expert consumers of AI outputs.
Knowing the right questions to ask?
Precisely. Algorithmic literacy means having the ability to ask critical questions. Where did the training data for this model come from? How does it measure and convey uncertainty? What are its known failure modes, especially if the environment changes? When is it likely to be operating out of regime?
So they can intelligently challenge the machine's recommendation.
Yes. Can they interpret the confidence score? Do they know if 98% confidence from this model is actually reliable in this context? Without that baseline understanding.
The human veto is just symbolic. They're just rubber stamping.
Exactly. It becomes ceremonial oversight, not meaningful control.
This really shifts the focus then. It's not about trying to eliminate friction entirely. Clausewitz said that was impossible anyway.
Right. Friction is inherent in war.
So the goal becomes shaping it, managing it.
That's the concept. Shaping friction, deliberately distinguishing between the good kind and the bad kind.
Bad kind first. What's dysfunctional friction?
Dysfunctional friction is just waste. Things that slow you down or cause errors without adding any value. Think opaque software queues where requests disappear, brittle data pipelines that break easily, complex bureaucratic approval chains for simple actions, unclear accountability, just grit in the gears.
And that stuff needs to be ruthlessly engineered out.
Absolutely. Streamline it, fix it, make it transparent.
But then there's constructive friction. Friction as a feature, not a bug.
Exactly. Constructive friction is beneficial delay. It's deliberately slowing things down just enough to allow for essential human judgment.
Like what? What judgment needs that space?
Crucial things. Validating a target one last time. Assessing proportionality is the military gain worth the potential collateral damage. Checking rules of engagement. Ensuring coalition partners are aligned before an action.
So building in pauses for critical checks.
Yes. And the source gets specific. It suggests embedding mandatory pauses, temporal buffers into decision processes. And crucially, the length of that pause should be keyed to the risk.
Higher risk, longer pause.
Precisely. A low-risk tactical target might require a very short confirmation pause. But a strike with potentially high collateral damage or major political implications should trigger a much longer mandatory pause, forcing more rigorous human review and explicit sign-off. It's about intentionally using friction to safeguard judgment and legitimacy against the pressure for pure speed.
Okay, if we need to manage friction, both constructive and dysfunctional, that inevitably leads to thinking about the architecture, command and control, C2, how do we build these systems?
Right. And the starting point, echoing Clausewitz again, is that big caution.
Yeah.
Whatever you build, don't create a single, easily targetable Schwerpunkt. Avoid that central point of failure.
Even if it promises efficiency.
Especially if it promises efficiency at the cost of resilience. The source actually analyzes 4 main architectural patterns, looking at the risks and how you might mitigate them. Each one has trade-offs.
All right, let's walk through them. Pattern 1, the obvious, tempting one, the centralized data fabric. The single fusion hub.
Yeah, put all the data in one giant lake approach.
Promises perfect awareness, but the risks.
Huge. First, as we said, it's that single point of failure. Take out the hub, you blind the force. Second, all that data flowing into one place creates massive, predictable network traffic, a big electromagnetic or cyber target for the enemy.
Okay.
Third, you get bureaucratic bottlenecks. Every request, every analysis has to go through the central node. Things can get bogged down.
So if an organization insists on centralizing data, how do you lessen those risks? What are the mitigations?
It comes back to distributing authority, even if the data is central. That means robust mission command pre-delegating authorities so units can act if the hub goes dark.
Got it.
Technologically, JP6 talks about priority circuits, ensuring critical data, like target validation, gets through the clutter. You also need smart use of edge caching.
Local copies of important data out in the field.
Exactly. So units aren't totally reliant on the live link back to the center. And crucially, you have to constantly rehearse degraded operations, practice fighting after the hub gets hit, using those minimal cache datasets.
Okay, pattern 2, the more traditional hierarchical hub and spoke, like a theater to man down to corps, divisions, brigades.
Yeah, the classic military pyramid. It's generally more resilient to total collapse than a single hub.
But it has its own friction points.
Oh yeah, classic ones.
Yeah.
Congestion at the hub nodes the core HQ, the division HQ. Information gets stuck. Battle rhythms get misaligned. The air picture updates every hour. The ground picture every 4 hours causes sync issues.
And just the time it takes to push information up and down the chain, especially classified data.
Exactly. Long classification chains, administrative delays, it all adds up.
So how do we fight that friction in an AI-enabled hierarchy?
It's a mix of tech and procedure. Better cross-domain solutions are needed to move data across security levels faster. You need strict rules, like time-bounded routing. If data gets stuck at one node for too long, it automatically tries an alternate path.
Smarter routing.
Smarter routing, yes. And constant reinforcement of commander's intent, pushed down frequently so people understand the goal, even if they lose perfect connectivity. And again, rehearsals. Practice operating when 70% of your links are down. Build that muscle memory for working through friction.
Right. And now we get into architectures more native to AI. Distributed mosaic kill chains. This sounds like the opposite of centralization.
It is. It's the resilience-focused approach. Instead of one big brain, you have multiple nodes, sensors, deciders, shooters that can connect in flexible ways to achieve an effect. Think many small parts instead of one big machine.
Avoids the single point of failure.
Definitely.
Oh, wait.
It introduces new kinds of friction, primarily coordination friction.
Getting all the different pieces to work together smoothly.
Exactly. If you have multiple AIs, multiple sensors, multiple units involved, how do you ensure they're all on the same page?
Yeah.
Using the same rules. Running compatible software versions. You risk model drift or version drift, where different nodes are operating on slightly different assumptions.
And the mitigation for that kind of friction seems to be where DARPA's Mosaic Warfare concepts really come in.
That's the argument. Mosaic is essentially a framework for managing distributed complexity. It relies heavily on standardization.
Standardization of what?
Things like a common intent schema, a structured way for commanders to state their goals that machines can understand, standardized interface control documents, ICDs, so different systems can actually talk to each other reliably.
Common plugs and protocols.
Basically, yes. And tagging every piece of data with its confidence level and its pedigree, where it came from, how trustworthy it is. The core ideas are composability and substitutability.
Meaning you can easily swap parts in and out.
Right. If one sensor breaks or gets jammed, the system can quickly find another available sensor and compose a new kill chain guided by that common intent schema. It's resilience through flexible recombination.
Okay, final pattern. Edge autonomy with periodic sync. This sounds like maximum delegation.
It is. This is where systems or formations operate largely autonomously out at the edge, deep in enemy territory, maybe, and only check back in with higher command periodically.
Maximum speed, maximum resilience if links are cut.
True, but also maximum risk of things going wrong without oversight.
What are the main dangers here?
The biggest is local optima. An autonomous system or a small unit makes a decision that's perfectly logical and optimal for its immediate situation.
But it might actually contradict the larger strategic goal or put other units at risk.
Exactly. It optimizes locally, but sub-optimizes globally. You also risk inconsistent interpretation of complex rules of engagement, ROE, out on the edge. And their threat models or understanding of the enemy can become stale if they aren't syncing back frequently enough.
So how do you maintain control when you've given systems that much freedom?
The controls have to be firm and built in. Again, positive human control is mandatory for any irreversible kinetic effect. No exceptions. That needs to be hard-coded.
Okay.
You also need automated ROE checks built into the software. The system should flag or prevent actions that clearly violate defined constraints. And, crucially, there must be a clear process for human-on-the-loop escalation.
Meaning?
If the AI encounters a situation it doesn't recognize, something truly novel or out of regime, it has to pause and kick the decision up to a human commander. It can't just guess when the context is completely new.
So looking across all these architectures, the big takeaway seems to be that the mosaic concept isn't just one option, it's almost a philosophy that applies to all of them.
That's a good way to put it. The source suggests mosaic warfare is essentially the strategic response to the inevitability of algorithmic friction. It starts from the assumption that links will break, models will drift, systems will degrade.
Failure is the baseline.
Failure is the baseline. Resilience doesn't come from preventing failure. It comes from the ability to rapidly adapt, recompose, and continue the mission using whatever assets are still working, all guided by that clear distributed commander's intent. Mission command principles enabled by composable tech.
We've talked tech, doctrine, architecture, but Clausewitz also stressed the moral forces in war: courage, leadership, will. How does AI interact with those?
It adds a new dimension. The source argues that alongside those traditional moral forces, we now have a critical new one: calibrated trust in automation.
Calibrated trust, meaning not blind faith, but not Luddite rejection either.
Exactly. Trust that has to be earned by the systems, earned through proven reliability, through explainability, through rigorous testing, and through processes that ensure accountability.
And this trust is moral because the stakes are so high, especially with compressed decision times.
Precisely. When the machine operates at speed, the time for human ethical reflection shrinks. So the trust you place in that machine that it will operate within defined ethical and legal boundaries becomes a crucial moral factor.
So how do we build that calibrated trust? The source mentions 3 pillars.
Yes. 3 key elements. The first brings us back to something we've discussed: algorithmic literacy.
Can't trust what you don't understand.
Fundamentally, no. The commander needs that ability to ask the probing questions we talked about data pedigree, uncertainty, failure modes. Understanding the tool's limits is the prerequisite for trusting it appropriately.
Okay, literacy first. The second pillar is interesting: principled dissent. This sounds like it's about culture.
It's entirely about command climate and leadership. It's not about the tech itself.
What does it mean?
It means leaders must actively create an environment where subordinates, technical experts, intelligence analysts, even junior officers feel not just able, but actually rewarded for raising red flags when they see something wrong, especially if it contradicts what the AI is saying.
Even if the AI is flashing 99% confidence.
Especially then. If a human analyst spots flawed input data or recognizes a situation where the model is known to be weak, they need to feel psychologically safe to hit the brakes, to say, wait a minute, without fearing they'll be shut down or penalized for questioning the machine or slowing things down.
Because without that culture, speed just locks in errors faster.
Exactly. You need that human capacity for skepticism and critical thinking as a vital check on automation. That requires deliberate cultivation by leaders.
Makes sense. And the third pillar?
Indivisible ownership. This loops back to accountability.
The buck stops with the commander.
Unequivocally. Moral and legal responsibility for the outcomes of military actions cannot be delegated to a machine or to the code or the contractor who wrote it. It rests solely with the human commander who authorizes the action.
No. The algorithm made me do it defense.
None.
Dead.
The commander owns the decision and its consequences, ethical and legal. This is fundamental to keeping war subordinate to responsible human agency.
So literacy, dissent, ownership. But again, the time pressure of AI makes living up to these harder. Which brings back the idea of temporal buffers.
Yes, those mandatory pauses we discussed under constructive friction. They are the practical mechanism for managing responsibility under speed.
Formalizing the pause.
Formalizing it, making it policy. Embedding mandatory delays into the decision chain, especially for higher-risk actions.
And the length of the pause tied to the risk level.
Explicitly. Low risk, maybe a few seconds for final human confirmation. High collateral damage potential or political sensitivity, maybe a 60-second or longer mandatory pause.
Why so specific?
To force that moment of human reflection, allow multiple checks, ensure proportionality is assessed, create that immutable record of authorization. It deliberately injects constructive friction precisely where the moral stakes are highest, acting as a counterweight to the machine's speed.
Okay, if these are the standards, how do we actually train leaders and teams to meet them? The source talks about changes needed in professional military education, PME.
Yeah, PME needs a significant update to address these realities. The source highlights 3 key areas for training focus.
First,
Better decision hygiene. We need to train leaders how to think and make decisions in these data-saturated, time-pressured environments.
Beyond just intuition or experience.
Right. Using things like structured analytic techniques to avoid cognitive biases, running time-boxed validation drills. You have 90 seconds to verify this AI-generated target package. And critically, using red teaming exercises.
But red teaming the AI.
Red teaming the human-machine team. Specifically, exercises where the red team deliberately injects corrupted, biased, or misleading data into the system without the blue team knowing.
To see if the human commander can spot the AI making a mistake based on bad input, even when the AI seems confident.
Exactly. Training them to be skeptical consumers to look for the subtle signs of algorithmic failure under pressure.
Okay. Better decision hygiene. Second PME focus.
Mission command with AI teammates. This goes beyond just understanding AI. It's about learning to partner with it effectively.
What does that involve?
It means training commanders to write machine-interpretable intent statements, clear, structured guidance that both humans and autonomous systems can parse and act on.
A common language for intent.
Yes. They also need practice testing, AI explainability features, making the AI show its work during exercises, and practicing authorizing lethal and non-lethal effects under realistic stress fatigue, time limits, conflicting data to build confidence and competence.
Got it. And the third PME area.
Integrating model governance as a formal staff function.
Treating the AI models themselves like any other critical military resource.
Precisely. Just like we have staff sections for logistics, S4, or intelligence, S2, we need a formal process and potentially designated staff responsible for AI model management.
What would they manage?
Things like validating new models before they're fielded, strict configuration control, ensuring everyone's using the correct tested version of the software, tracking performance, investigating incidents or failures, managing updates. It needs to be a disciplined, professional process, not ad hoc.
Bringing rigor to the AI lifecycle within the military structure.
Exactly.
Formalizing the oversight.
So this detailed analysis, the types of friction, the C2 issues, the trust pillars, the PME changes, it all culminates in some very concrete policy recommendations for the military.
Yes, the source lays out 6 specific actionable recommendations aimed primarily at the U.S. Army and the broader Joint Force. They basically synthesize the whole argument.
Let's list them out. Number 1.
Engineer constructive friction. Deliberately design those verification pauses into AI-enabled systems. Codify the pause lengths based on risk categories in standard operating procedures, SOPs.
Okay.
Mandate positive human control for all kinetic destructive actions. Back this up with immutable logs and audit trails for clear accountability. Non-negotiable.
3.
Debrittle C2 by design. Actively resource things like edge data caches, ensure multiple comms paths exist, use priority circuits for critical data, and force units to rehearse operating in degraded C2 environments quarterly. Make resilience routine.
Institutionalize algorithmic literacy. Make understanding AI fundamentals pedigree, uncertainty, limits a mandatory, examinable part of PME for officers, probably starting at battalion command level and up. Certify leaders in AI risk assessment, adopt Mosaic principles for composability, ensure new systems are fielded with standardized interfaces, ICDs, and use clear confidence pedigree tags on data. Build for interoperability and substitutability from the ground up.
And number 6.
Update commanders' intent products for machine consumption. Require commands to publish intent in concise, schema-based formats that machines can parse. Evaluate the effectiveness of these products in training exercises. Bridge the human-machine communication gap doctrinally.
Wow. Okay, that is a comprehensive look at a really complex intersection. We started with Clausewitz's old idea of friction and saw how AI doesn't eliminate it, but twists it into these new challenging forms. Data overload, model bias, the risk of brittle, centralized systems.
Yeah, the character of friction changes completely, from scarcity and delay to saturation and opacity.
But that Clausewitzian Trinity, passion, chance, reason, that still provides the anchor. The reminder that war is political.
It has to. The machine serves the policy, not the other way around.
Yeah.
That shifts the whole focus. It's not about chasing maximum speed at all costs.
It's about preserving human judgment, control, and legitimacy within these faster, more complex systems.
That's the core tension.
So the final takeaway seems to be, friction isn't necessarily bad. Unmanaged friction is bad. Dysfunctional friction is bad.
Right. But constructive friction is essential.
And if the military deliberately builds in that constructive friction, mandates that positive human control, and really develops genuine algorithmic literacy in its leaders,
Then AI doesn't have to replace human judgment.
it can illuminate it, help humans make better judgments faster within the chaos.
That's the goal, using AI to augment, not abdicate, human responsibility.
Which leaves us with a really potent final thought based on that tension between centralization and resilience.
Yes. We talked about how organizational friction, that temptation towards efficiency, often pushes commanders towards building that single powerful data hub, the targetable Schwerpunkt.
Right, the allure of perfect information in one place.
So the provocative question for you, the listener, to chew on is this. How can military leaders realistically balance that seductive promise of perfect centralized efficiency with the absolute necessity for distributed resilience that a contested, failure-prone battle space demands, where system failure isn't just possible, it's guaranteed?
Finding that balance between efficiency and resilience in the age of AI, that's the tightrope walk.
It really is.
A perfect place to leave it. Thank you for that incredibly insightful breakdown.
My pleasure.
And thank you for joining us for this deep dive into algorithmic friction. We'll see you next time.